Take a moment to think about the vastness of the universe. If the solar system were compared to a grain of sand, what would we say about the rest of the cosmos? We'd be floating in an infinite desert, surrounded by trillions of other grains, each with its own story to tell. But what if I told you that within just 100 light years, a relatively small space in cosmic terms, there are thousands of stars? Some of these stars are so faint that we can barely detect them, while others shine so brightly that they can be seen from thousands of light years away. And here's the most intriguing part. Many invisible objects are lurking in these dark depths, from massive brown dwarfs to rocky exoplanets that could be similar to our Earth. These numbers are impressive, but they're only a fraction of something even larger. Picture the Milky Way, our galaxy, containing approximately 200 billion stars and trillions of planets. With that in mind, it's almost impossible to explore all these wonders. Are we alone? Or could life be out there somewhere, waiting to be found? Did you know there are about 50 star systems located less than 15 light years away from us? It might sound like a lot, but in cosmic terms, this region is considered sparsely populated. Think of it as living in a small, isolated town where your nearest neighbors are miles away. In some of these systems, we find solitary stars, while others have 2 or more components, like stellar families living together. Altogether, there are about 65 stars in this neighborhood, and many of them have exoplanets or disks of gas and dust, where new planets might still be forming. Now let's travel 6 light years from our Sun and reach Barnard's star, a small and cool red dwarf. What makes it so fascinating? Well, this star is always on the move. It's moving so fast across the sky that, in about 10,000 years, it will be the closest star to our solar system. But don't be fooled by its proximity. Barnard's star is so faint that even when it gets closer, you wouldn't be able to see it with the naked eye. It's like a distant light bulb on a dark night, too dim to notice without help. In 2018, scientists discovered that this star might have a planet orbiting around it, an exoplanet called Barnard's Star B, with a mass at least 3.2 times that of Earth. But before you imagine a second Earth, here's a fascinating detail. The temperature there is a freezing 270 degrees Fahrenheit. Think of it as an eternal winter, much colder than anywhere on Earth. Still, some scientists believe that beneath its icy surface, there might be an ocean warmed by internal forces. And if there is life there, could this planet harbor life forms completely different from what we know? Now let's radically change our scene. On the other side of our Sun, we find Sirius, the brightest star in the night sky. When we look at Sirius from Earth, it appears to be a single, intense source of light. But in reality, Sirius is a binary system, made up of 2 stars, Sirius A and Sirius B. Sirius A is a blue-white star, about twice as massive as the Sun and 25 times more luminous. Sirius B, on the other hand, is a white dwarf, an ancient star that has already passed its peak and is now small and dense, with an extremely high surface temperature. Despite its brightness and proximity, scientists have not found any planets around Sirius. How is that possible? Could the intense radiation and stellar winds from Sirius A prevent the formation of planets? Or maybe Sirius B, during its transformation into a white dwarf, destroyed any material that could have formed planets? These are questions that continue to intrigue astronomers today. Now our journey takes us to Wolf 1061, a red dwarf located about 14 light years from Earth. This star isn't known for its brightness, but for the planets orbiting around it. Wolf 1061 has 3 exoplanets, and one of them, Wolf 1061c, is in the star's habitable zone, where conditions might allow for the existence of liquid water. Does that spark your curiosity? Wolf 1061c is about 4 times more massive than Earth, which classifies it as a super-Earth. But what really stands out is its equilibrium temperature, which is around 60 degrees Fahrenheit. That's a bit colder than Mars. But who says life can only exist in Earth-like conditions? What if this planet has a thick atmosphere that retains heat? Or maybe it has ice-covered seas with liquid oceans underneath? If that's the case, Wolf 1061c could be one of the best candidates to harbor life outside our solar system. Now, let's talk about what surrounds all of this. Our solar system is traveling through a region known as the local interstellar cloud. Imagine it as a bubble of hot, rarefied gas, with a temperature of about 7,000 Kelvin. To put that into perspective, that's equivalent to more than 12,000 degrees Fahrenheit. But don't worry, we're protected from this radiation by the sun's magnetic field and Earth's atmosphere. The local interstellar cloud is just one part of a much larger structure called the local bubble, which was formed by supernova explosions about 10 to 15 million years ago. Our solar system has been traveling through this bubble for thousands of years and will eventually exit it, entering a new region of space. Our next stop is AP Columbae, a young and rebellious star located 27.4 light-years from Earth. AP Columbae is special for several reasons, but the most fascinating is that it was born just 40 million years ago, when the dinosaurs had already disappeared from our planet. What makes it even more intriguing is that it formed about 450 light-years from its current position. Imagine a star being expelled from its stellar nursery and launched into space like a cosmic cannonball. This star is a very small red dwarf, with only 13% of the Sun's mass. But don't be fooled by its size. AP Columbae is a true explosion machine. It emits violent flares, releasing large amounts of radiation into the surrounding space. This makes it a hostile environment for any exoplanet that might be orbiting it. However, these flares and the unusual amount of lithium in its composition are signs that it's still in its early stages of formation. Studying such a young star can teach us a lot about how stars and planetary systems form. Now we travel 37 light-years to Gliese 370, an orange dwarf star. In 2011, scientists discovered an exoplanet in its orbit, Gliese 370b, which quickly became one of the most interesting exoplanets in the search for life. This planet is about 4 times the mass of Earth and is located in the star's habitable zone, where liquid water could exist. But here's a fascinating detail. The average temperature on Gliese 370 might be around 77 degrees Fahrenheit, similar to a tropical climate on Earth. However, the density of the atmosphere could be a decisive factor. If it's too dense, the planet could turn into a suffocating greenhouse. But if it's moderate, Gliese 370b could have vast shallow seas and a mild climate, ideal conditions for the development of life. And if there is life there? What kind of beings could inhabit a world with 40% more gravity than Earth? Now, let's move 50 light-years away to find the Castor system, a true stellar puzzle. Castor is a complex system, composed of 6 stars orbiting each other. This is the kind of system that challenges our understanding of how star systems work. Each of these stars has its own story, but together they form a celestial symphony that can teach us a lot about the dynamics of the universe. What's even more intriguing is that despite its complexity, no exoplanet has been confirmed in the Castor system. But who knows what could be hidden in the shadows of this system? Perhaps one day we'll discover planets orbiting these stars, offering spectacular views of skies with multiple suns. Our solar system is located within the local bubble, a gigantic structure that extends about 300 light-years. This bubble was formed by supernova explosions, which heated and ionized the interstellar gas, creating a region of low density but high energy. What's fascinating about the local bubble is that it's not alone. There are other bubbles, like the Antares bubble, and they're constantly interacting with each other. In the future, our solar system might move out of the local bubble and enter a new region of space with completely different conditions. Who knows what else we'll discover as we explore farther and farther away? And what about you? What do you think? Is there one of these systems that piques your curiosity the most? Leave your comment below and share your ideas on where we should explore next. And don't forget to subscribe to the channel and share this video with other cosmic explorers like yourself. Thanks for sticking with me, and until next time.